Okay, we'll take this part as well. So I'll be recording this as well. Let's see. Okay, what about the next one, dear? 27, right? First. Okay, you were telling the answer actually. You were telling me the answers. The steps for the preparation of pure sample of sodium nitrate is listed, and also, yeah, what's the answer? Titrate with dilute nitric acid. This is first one, yeah. Then evaporate the concentration of solution. What is that? Rinse out the conical. Add the indicator. Okay, fine. Pipette and on volume. Blah blah. Okay. Cool and filter and remove the crystals like that, right? Repeat using the same volumes of aqueous sodium hydroxide and dilute nitric acid, but no indicator. Okay. What are the steps? First, pipette out. No, isn't it? Huh? Yeah, it's the D, right? Oh my God, that was so easy. That was so easy, right? How? If you know the first step, that's it. There was no confusion because I mean they have not given any other confused answers except for the answer that's starting with the number 5. They have not given another option, right? Because usually we have to start this the whole thing by taking a volume of aqueous sodium hydroxide or aqueous the base or acid into the conical flask, and then only you start the titration according to this set. I mean, according to these answers, right? According to your statements here, first you have to put out the substance into conical flask, then only you can titrate. No, the other one they have not said filling up the burette part, so that filling up the burette part is not there, right? Because of that, we have to start like that. Oh, is it 3? Rinse out the conical flask. Can we say rinse out the conical flask as number 1? No, like the step number 1. No, 5 as number 1. It should be better. 5. It is better, right? Yeah, rinse out. They say rinse out, not that like rinsing might give a like slight confused answer idea for you, thinking like, yes, we have to start this conical flask by washing the conical flask. You might think that we have to wash the conical flask and start, but the point is this here, they're talking about the washing of the conical flask in the middle of the process. That means after doing it one time, after titrating one time, you have to wash it out, right? We wash the conical flask and then do it again like that. That rinsing part, that's what they're referring here by rinsing out. Okay, so don't take that as number 1. Step number 1. Step number 1 should be in this particular scenario. I'm telling you, can be depending on this. So that's why we say your understanding should be good, your English should be good, your reasoning should be good to get this thing sorted. Right? It's just not that you're going by heart and we can't teach you just one hard answer and say this is the answer. You study by heart this one and go and write. You can't tell like that, right? It's your reasoning power, right? You have to think like this. Rinsing out cannot be the answer, like starting point here. It should be the pipetting out as number 1, right? So like that, you have to rule out. This should be number 1, right? Like that. Then if from that itself, you can find the answers. That was good actually. If you got the first one correct.
B, right?
D. D. Okay. Yeah, called Marcus
Yes,
chemosis
yes,
D.
okay.
Yeah. Okay. So, because that first one itself is like first point is if you found the first point from there, and again you can go ahead. You can see this number, other numbers. 4 is actually at the indicator, and then 1 you can titrate it. Yes. Then 3 rinse out the conical flask. Then number 7, repeat this using same solution and the dilute nitric acid now without the indicator. And then 2 you can evaporate the concentrated solution, evaporate to concentrate the solution, and then 6 you can cool and filter out the crystals or filter to remove the crystals, right? That's the point. Okay, you have done that. Okay, what about this one? 28. A white compound is insoluble in water, right? What's the question? Okay, what's the answer?
C.
Cation and iron, sorry. It's white and it's insoluble in water. How about that? It
C.
should be insoluble, so it's calcium. It can be a calcium carbonate, right? You can see these things. You know, all nitrates are soluble. Remember solubility theory? All nitrates are soluble. All sodium ions are soluble, right? But in their question, they're asking insoluble one. In that case, our both answers here, sodium will get cancer, nitrate get cancer, right? They are all soluble. No? So the option which is good is this one, right? It shows only calcium and carbonate is insoluble. Yeah, that option. This option can't be because of the nitrate's presence. Okay, right? This is the only option possible. No, see now. Okay.
Yes.
Yes.
I see, right? Yeah. Okay. Right. What about the next one? Are you other people? Are you okay, children? These two answering, right? Right. Okay. 29. The flow chart. Okay. The flow chart describes the preparation of ammonia sulfate. Okay, fine.
A.
This is a Haber process. Yeah. Wow. Contact process and both are there together. Okay. What are the elements 1 to 4? One is what? Haber process has two elements, nitrogen and oxygen. Right? Number 2, oxygen. Okay, that can be. Number 2, oxygen. Number 3 can be hydrogen. Yes, nitrogen, hydrogen, and sulfur. Yes, yes. Ace. A says the answers. Like anyway, you know, Haber process means what? Where you make ammonia, right? Ammonia, NH3.
Ammonia.
So to make NH3, you need to have N2 and H2, or maybe H2 and N2. Depends on that. That doesn't matter. From nitrogen, sorry. They're telling from the air you're taking. You take from air. What do you take from air? Nitrogen, not hydrogen, right? Not hydrogen. Hydrogen you take from what? What is the way that you're getting hydrogen for this process? For Haber process, we need hydrogen. How do you take that hydrogen? Yes, people who have memorized, let's see. How do you get this hydrogen?
From electrolysis of water.
No, darling, that's more expensive. I mean, you know, electricity is costly, no? In Sri Lanka also, you assume like that, right? Electricity is very costly thing. They really can't use
Reaction
that.
of a metal with a
Whoa, wow,
acid.
another one. Wow, wow, wow. What about that? That's another one. Electrolysis is also costly. Okay, then you cannot get metals extracted without but electrolysis sometimes, right? To purify, you need electrolysis again. And extraction is process is also expensive, isn't it? Electrolysis process, I mean, extraction process also has electrolysis partly, like I think in some metals like aluminium, in some other metals in the higher level, the top level, you have to go for electrolysis, right? To make it purify. So you can't use that also because it's also again energy consuming. The method is actually there in organic area. In organic, you learn that cracking. It's cracking of ethene,
Wow.
right? You get hydrogen from cracking, no? By cracking of ethene, that's the method. So that hydrogen is used in Haber. Yes, it's organic, right? From organic to Haber. Huh? Right, what about this one? Element 2 comes from air is oxygen here, right? And contact process, you need another element that is sulfur, right? Sulfur here, yeah. So sulfur with oxygen, you get sulfur dioxide. Yeah. So these are the ton stuff. Yeah, the two gases that come from the air. You need to just filter this stuff, right? Air, element, like that, right? Okay. Okay. Other ones are wrong because that's 30th. Now we're going to go to organic part. Yeah, sure. We're coming to that. Let's see your organic. Yes, you might remember that very well. I think you did it recently. Right. Which row correctly shows the possible uses of sulfur dioxide and sulfuric acid? Possible use of sulfur dioxide and sulfuric. How would you have to tell this? Sulfur dioxide is a yeah, this is a very tricky part. According to your book, sometimes your answers go wrong. I mean, that's a little bit tricky area here. Yeah, okay, let's say you're saying A. Sulfur dioxide as a bleach. Sulfuric acid as a battery acid. Okay, fine. Battery acid is anyway correct. Right? Sulfuric acid is used as a battery acid. That's correct. Sulfuric acid is not used as a bleach. So, sulfuric acid is not, yeah, it is, this one is correct. Used to make fertilizers. It is also correct. But in this case, this is wrong, right? Making fertilizers, you don't use sulfur dioxide to make fertilizers, you use sulfuric acid. Actually, sulfur dioxide is inside this sulfuric acid, true, but we have to take it separately, right? We have to consider them as two different entities. So sulfur dioxide can be used as a bleach because it bleaches the color of the litmus. Remember, litmus paper changes. Like we can't test litmus using this one because it bleaches it. We learn that rule and then we say, okay, because of that, use potassium permanganate, right? Soak paper to test sulfur dioxide. It can turn the color change, right? It can show the color change. That's why we go for that method. Litmus cannot be used even though this gas is acidic, right? Because it bleaches, right? So killing bacteria in food, but that's correct. This one is correct. This point is also correct. This point is correct, but this second option is wrong in that case. No, making detergents by sulfur dioxide or sulfuric acid. This is wrong, right? Yeah, making detergent is done by sulfuric acid. So our options, both options are correct in this case. These two options. A only has both options correct. The others have at least one of them wrong. Misstep, misplaced. Okay. You just have to read carefully, children, and it's all theory. That part was directly from theory, right? Theory, right? Okay, and the next one, 31. Selenium is in
D.
group 6 and gallium is in group 3. Which prediction can be made from this information? Gallium atom has 3 more protons than selenium atom. Okay, is it correct? Gallium has 3 more protons than selenium. Selenium is in the group 6. Gallium is in the group 3. So A is wrong, right?
No,
A is
gallium
right.
has
More
less.
less electrons. Yeah, that's less protons. Okay, less electrons, less protons. Right, gallium is more likely to be form the negative ion than selenium. That's wrong, right? This is in the 7-6 group. It's like oxygen. So in case you can't like get an answer easily, take this as oxygen and think of this one as aluminium. Right? These two guys, take it like that. We can know, oxygen forms a negative ion, right? And aluminium forms a positive ion. So that's also wrong. Then the next one, selenium atoms have fewer valence electrons than gallium atoms. Is that correct? Selenium atoms have fewer valence electrons than aluminum? No. Because selenium is in the 6th group, it has 6
No.
valence electrons. What is valence electrons? Anyone having problem? Valence electrons? Yeah, outer shell electrons, right? In the group 6 elements, they have 6 electrons in the outer shell. Group 6, 6 electrons. Group 3, 3 electrons in the outer shell. Isn't it? So this is also wrong. Selenium has more non-metallic character than gallium. That is correct, right? That is correct because now that's going to be the non-metal side, yeah. Selenium is on the side of the 6th side. They have particularly given this in a way that jumbled. I know they have jumbled it up and given the sentences. So just trying to check whether the people just memorize or by heart and come and write science exams, right? That's the thing. So that is what they want to say, right? IQ. Okay. So basic area of testing is here. I have told that it's not just chemistry they check in chemistry paper. Mostly the chemistry subject they check with I check. They can use check to check IQ. I hear they just use that switching and asking in the different places to see how you're thinking. Okay, how fast and how clearly you can think. Which statement about some metals and their compounds is correct here? Calcium reacts with cold water but not with steam. Wow, is that correct? Calcium, if it can react with cold water, of course it can react with steam, right? Calcium reacts with cold water, true, right? And also it can react with steam then. Terrible. It will be dangerous. We don't try that. It will be like the dangers in not sodium, but it's just coming below sodium, potassium, just calcium, right? Just like just after sodium, potassium, you get calcium, no? Yeah. In the reactive series. So kind of strong, like weak, reactive one, no? So if it reacts with cold water, it reacts with steam too. So lead carbonate decomposes at a higher temperature than zinc carbonate. Is that correct?
Yes.
Lead or zinc is on the top, children?
Zinc is more reactive, so it decomposes at higher.
Yeah. It decomposes at higher temperatures? Zinc?
Zinc decomposes.
At higher temperatures, you're saying?
Yeah, zinc decomposes at higher temperature.
Yeah, okay. That means lead is not, right? Lead is not decomposing at high temperature. Zinc,
No.
yeah, okay. The point is that, yeah, lead is lower in reactivity than zinc. That means it is easy to decompose. That's the point, of, right? The point is that they have given the statement in a tricky way. They ask you, lead carbonate decomposes at a higher temperature than zinc carbonate. The point is this, lead is actually below zinc. So the below ones can be actually easily decomposed, right? They don't have to be a higher temperature compared to the other guy, like compared to higher element. The higher element here is zinc. So you cannot take that, right? That is wrong answer. Then again, the next one, wrong. So the point is wrong here. statement is wrong, right? What about the third one? Magnesium can be extracted from its oxide by heating strongly with carbon. Is that correct? Is that correct, children?
No.
This is wrong, right? Magnesium cannot be extracted using what? Carbon. Why is that? Magnesium is
Magnesium is more reactive than carbon.
yeah, magnesium is above carbon, so it
Yes.
can't be extracted using carbon. That means carbon cannot displace it, right? Yeah, magnesium is above carbon, no? So cannot be extracted using carbon. That means carbon cannot displace magnesium. Carbon is below, right? Okay, pure aluminum reacts with cold dilute hydrochloric acid. Is that correct?
Yes.
That is correct, right? Okay, so it's 32, no? Yeah, that's correct. D. So your
How
answer is correct. Why? ACl? Pure aluminum reacts with coal. It's a metal, no, darling? Pure aluminum, why they have mentioned pure aluminum is also because, aluminum oxide is a little bit strong, but still it will also react. Right?
Okay.
It will also react. No?
I thought it was aluminum oxide.
Here it's aluminum, just aluminum, right? Aluminum oxide also reacts. It's also base, isn't it? We learned that it's a base. Okay. So
It protects
aluminum oxide
aluminum.
protects the aluminum from water, not from the acids. It's a base then. Aluminum oxide can react with acids, darling. It's a base then. Okay.
Okay.
It cannot protect from the acid. It can protect the container from water. Okay. From strong acids, it can't.
Water and oxygen. No.
Water, yeah, oxygen is the coating, so it protects it from the water. Like it doesn't let the water go through. So there won't be further corrosion, we say, right? There won't be further corrosion. It doesn't dissolve in water. It's strong, then it doesn't dissolve in water, but it dissolves in acids. Yeah, that's why they say don't cook your pickles in your aluminum pots and pans. Okay, don't cook the pickles or mango curry in the aluminum pots and pans because still the aluminum can react. Or even aluminum oxide can react with acids because of that, right? Okay, the next one, number 3. Sorry, 33. Oxygen story. Oh my God, this small time story has been given. Wow. See now, you people telling that it's not there. This is Joseph Priestley's experiment, right? Okay, what happened? What's correct? Oh, that's so simple. See, Joseph Priestley's experiment, right? Okay, why A is wrong and the water doesn't go down? It uses up oxygen. You can see this yourself. Just try it in the glass of ice, like glass of glass turned upside down under a candle, and some colored ink you can put, right? Some colored ink. You can see the color like just rising up, and it goes up about like how much of the container will be filled up with that, children? Just yes.
21.
21 exactly, but you might not see that kind of a thing in the glass. You might see it as what, 20% from 100, right? That means it's like 1/5 portion. It's like 1/5 portion. Okay, it's like 1/5 portion. 1/5, no? Right? So like not half, not directly half. Get it? Okay, it's not D then, C. It's not B, of course, it's
Yes.
not A. Okay, that's Joseph Priestley's experiment, no? This is how he found out oxygen. Okay, I mean he discovered oxygen using these kind of experiments, right? Right. The addition reaction between hydrocarbon X and bromine forms only one product. Okay, what is it? Hydrocarbon X and bromine. Which compound is X?
B.
B or D? What is it?
B.
B. It's only an alkene, right? Only an alkene can react with bromine here to give the decolorized product. That is, product is what? It's going to be like this. Now, if you had the bromine, sorry, whatever the alkene, you get this alkene change it what? This double bond changes, and you get the two sides attached to bromine, right? So you're getting only one product here, right? Isn't it? That bromine will be attached to the sides while hydrogen was already there, right? It's an addition reaction, isn't it? Still the addition reaction, right? Bromine was just added to the adjacent carbon atoms, right? So there's only one alkene here. This is an alkane. Sorry, this is methane. It's not the possible answer. This is ethane, not possible. This is alcohol, not possible. Right. Only ethene. That was organic. So easy. So very easy. That's why you see children now. Though you said organic and polymers are difficult, you see in the MCQ paper, you get mostly them correct, right? Mostly the questions that you get from organic and polymers, you get correct. The last question, right? After learning the lesson, the still you can get wrong in the other questions. The inorganic part, they can trick you. There's a lot to read sometimes, right? And a lot to filter. Okay, now 35. What's the answer? Organic is easy, therefore, and polymers. Okay, you're saying here, naphtha, okay, X and this part, okay, from naphtha you get this thing, and from that thing you get this kind of a thing. Oh, right, again, organic direct reactions, right? Only a few reactions are there in organic to study, isn't it? Right, so X is actually cracking. This is from naphtha, you get a small molecule. This is a small molecule, right? Just 3 carbon atoms, huh? So, naphtha is a
Why
fraction
is
of the, huh? I'm not sure. I don't know which one is correct. I didn't say that, darling. I'm not sure actually that one. Right? One of them. I just mentioned that. Cracking is correct, I said. You have to check the other one. I still didn't come to that. Okay, why is what? It's OH minus. Yeah, you have not OH minus. OH group added here. You're adding an OH group here to the double bond. To the double bond, you can add the OH by doing what kind of reaction? It is the reaction with steam. Yes, not fermentation. It is reaction with steam. Yes. It's not the biological method. It is the chemical method. Isn't it? Okay. I was actually marking just cracking only. That's why I was not referring to the other question, other part. So the answer option A. Yeah. 2 reactions. But no, again, that's easy. That was again very straightforward questions, right? Simple, no? Okay, what about alcohol question? Last one, last few. Hurry up. Last few children. Still fast. Which statement is correct? Alcohol 2. What? You're saying alcohol 1 can be made by addition of steam to alkene. Alcohol 1 can be made by alkene. Alcohol 1 is what? Only one carbon atom is there, right? This is methanol. Methanol, is there an alkene that we can make methanol from? Do we have an alkene called methene? No, there's no alkene, right? To start with an alkene, I mean, there should be a double bond of carbon-carbon. Carbon double bond should be there. Carbon-carbon double bond should be there. That means there should be 2 carbon atoms to start an alkene group, right? So at least 2 carbon atoms are needed to start the alkene group. That means we have to start, this is the first alkene, ethene. So there's no methanol that comes from an alkene, right? Alcohol 1 cannot come from an alkene. There's no alkene that makes alcohol 1. Alcohol 2 can be made from glucose. Is that correct? Alcohol 3 is a renewable
Yes.
energy source. Okay, alcohol 4 has only one other isomer. No, right? Alcohol 4 has many isomers. Remember, this OH can be placed in the second carbon group we learned. And then also we can take this methyl group, we can break and come to the, like take it to the middle. There were some answers like that, right? So there's 2 more options possible. So that is also wrong. Isomers are actually possible. Several isomers are possible when you get the butanol, right? It's because OH can be changed to places and this branch also can be broken and fixed in different places, right? Okay, alcohol 3 is renewable energy source. Is that correct? Propanol? Isn't it? Alcohol 2 can be made from glucose, ethanol, no? Which one is the answer?
B.
What is the answer? You're saying D. B. B or D? B. Yeah, that's correct, right?
B.
Renewable energy source has a problem. Yeah. Yeah. Alcohol 4 has an only one isomer anyway, wrong. Yeah. And this is also wrong. And then alcohol 2 can be made from glucose. You have learned this. This is ethanol, no? Ethanol comes from glucose. You have learned, right? That's how they make ethanol in the world, first place. Right? Okay, what about the next one? Which compounds use have the molecular formula C3H6O2? What is this? C3H6 and O2. You see, I have told you to take a tip like here. This is C3H6. It's like alkene group. Alkene plus O2. I have told you alkene and O2 means what is it? It's like acid, right? It's like acid. Okay, so you can take one acid here. One of the acids that yeah, this is the general formula of acid. Propanoic acid is correct, no? Anyway, propanoic acid is correct. Then anything else? Because there's esters here, you have to check that as well. Esters. What about the general formula of esters? You all don't learn like that. But if you say esters, general formula, children, remember they are also R1. You have carbon double bond O, and there's one O, and there should be another R group, right? Like R2. Okay. So in ethanol, like sorry, if you had this ethyl methanoate, if you check ethyl methanoate, okay, that will also contain 2 oxygen atom, and there will be ethyl group. Just write it here and see C2H5 here. And on the other side, you have what? Methanoate. So there will be C double bond O and 1 oxygen, and then you have here methyl group. Look at that, right? This one, if you write it and see, you see there's, oh, how many carbon atoms? That's wrong. Methyl, sorry, this part. It's just one hydrogen, right? So methyl ethanoate, yeah, this one. Methyl ethanoate also has the same number of hydrogen, 2 carbon, 2 oxygen, and how many hydrogen atoms? 6, right? So that's correct, right? See, methyl ethanoate also gets the same kind of a formula like acids, right? That means the propanoic acid. That means general formula for, or the molecular formula of acids, carboxylic acid, is the same as the esters, right? Okay, an ester that contains same number of carbon atoms will be like mapping with that same number of carbon atoms, right? If you have same number of carbon atom means now propanoic means 3 carbon atoms now, right? You can think like that also, children. Or as here, this is two carbon atoms in ethyl, and methanoate means 1 carbon atom, right? Together it becomes 3, right? And here also 1 carbon atom in the alcohol group, 2 carbon atoms in the acid group. So that is also 3, isn't it? So these all 3 have the same formula, same general formula. In the case of like you're normally not learning the esters general formula. So in that case, you can write it down and get it, right? You can just write the ester. One of the esters, if you wrote, you will see that it's the same as the acid. Okay. The general formula of this one, ester, H. This first one I just drew. Methyl ethanoate I drew, right? Ethyl methanoate I drew. Ethyl methanoate I drew. So I found out the molecular formula of ethyl methanoate, and that was the same as the propanoic acid, C3H6O2. So after that, I can say it's the same. Of course, it will be the same now because methyl ethanoate and ethyl methanoate will have the same kind of carbon atoms, isn't it? Because it's methyl group here on the alcohol side. In this case, ethyl group from the alcohol side. The same thing. It will be the same thing. You can draw and see. You can figure it out without like drawing. It will be easier for you. Okay. So remember now from there, right? Esters have the similar, or esters have the same general formula like acids, carboxylic acids, of the same number of carbon atoms, right? That contain the same number of carbon atoms. If you have the same number of carbon atoms, they are the same. Okay. What about next one? So the answer is actually D. Okay. What about this one? An organic compound has empirical formula here. Right. What about the answer? Yeah. A?
C.
C, yeah, C2H2, sorry, CH2O. Where's CH2? C2H4O2. Yeah. Ethanol shows that, no? C. Let me see. This is 38, right? You're saying C.
Yes, teacher.
Oh, the C, this name is wrong, my child. It's a D, right? Is it C or D? The structure is correct, what you said. Like you check for the structure. What about the name? Ethanoic acid, no. The D is correct. Yeah, the name was wrong here. Ethanol, the name is wrong. Ethanol, it's not ethanol. It's the carboxylic acid, right? It is ethanoic acid, right? This is the carboxylic group, ethanoic acid. Okay, right. Then that is because of that, D is correct. Last one, sorry, last two. Which statement is correct? Complex carbohydrates. Yeah, batteries of God. Yeah, okay. What about carboxylic acid? Complex carbohydrates such as the starch, hydrolyzed by using use simple sugars. Is that correct? Fats have the same amide linkage? No, nonsense. Fats don't have amide linkage, right? This is ester. Fats have ester actually. Amide is wrong. The word amide is wrong. Yeah. Which one is correct? Sorry, oh my god. First one, complex carbohydrate like starch are hydrolyzed to give sugar. That's correct. Yeah. C is, yeah. What's wrong with C? What's wrong with C and D? Tell the points. Why are they wrong? Why are they wrong? What's wrong with them? I mean, this is amide point.
They have the same linkage.
Proteins and nylon are
Might be.
polymers formed on the same monomers but different linkage. Different is wrong. The word is wrong. Not different is actually amide, the same linkage. Yeah. So proteins are natural polymers and also called polysaccharide. That's wrong. Proteins are not polysaccharides. Carbohydrates are called polysaccharides. Right? Okay. So like starch, you can say starch, glycogen, they are polysaccharides. Proteins are not polysaccharides. So the first one is anyway correct. Right. So you rule out the wrong ones always.
Excuse
Yes,
me,
I do.
miss.
Yeah, I do.
Why?
Then proteins are just polymers.
Proteins are polymers, yeah, made of what? Amino acids. They are macromolecules, you can call. They are polymers, you can call. They are large molecules, you can say. Similar terms is fine, still fine. You can say biological large molecules made of amino acids, right? They are not made of what? Glucose, right? If they are made of glucose or sugars, you can say. If they are made of sugars, you call them polysaccharides. The carbohydrates are called
Okay.
carbohydrates. We have categories: monosaccharide, disaccharide, and polysaccharide. So it's never coming under carbohydrates, no, right? Proteins are coming under. It's a different category, different group of nutrients. They contain nitrogen, no? So they're different. Okay. What about the yes functional differences as well? Yes, repeat unit of this one.
Vegan
Sorry, dear? Huh? What?
39.
Yeah. What is
Answer
the
B is wrong because
yeah answer?
amide linkage.
Yeah. Fats don't have amide linkage. Fats have ester
It is-
linkage. Sorry.
Ah,
Fats have ester linkage.
it's-
Yeah, ester linkage. Like pteroline.
Okay.
Pteroline is correct. Pteroline and fats have similar thing, but it's not the amide linkage. It is a ester linkage. Yeah, that point. Okay. So rule out the wrong things like that. Then next one, what is this? Repeat into polymer. This polymer is shown. What is this repeat? What is the monomer? Yes, you have to draw the double
A.
bond here, right? It's just simply draw the double bond in the middle of this,
A.
and then yeah, you'll get the double bond here. Where's how we draw the double bond here and cancel these bonds here. You will get to see the compound. Then CH3A is that A? Yeah, because it's turned upside down, but you still see the same thing, isn't it? Oh, is it correct? A or am I getting it correct? CH3 and HN? No, CH3. Yeah, that's the only one which is correct, right? Yeah. So HNCl. Okay, they're crazy way. Okay. H and Br they have mixed up and given, but still CH3 and H should be in the same carbon atom. That's the point, right? You have to take one carbon atom as one, like CH3 group and H should be in the same carbon group. Chlorine and bromine atom should be in the other carbon, right? Here in this one, it's not. It is not. In this also not. Chlorine and bromine are not in the same carbon atom. Here also chlorine and bromine are not in the same carbon atom, so they are wrong. But this one has a chlorine and bromine in the same carbon atom, right? So hydrogen and methyl group also in same carbon atom. You are not learning stereoisomers in all levels, so you can take this as the correct answer because we don't care about that whether this side is changing. I mean, the same options like the sides have changed, that doesn't matter, right? Okay, you can take methyl group up or down, H group down or up, that doesn't matter. But anyway, the same carbon, that particular carbon should have the bonds that it had. Chlorine and bromine, if it has chlorine and bromine, it should be either bromine and chlorine up or down, that doesn't matter. But anyway, the same group should be there attached to that carbon atom, right? Same group should be attached to carbon, chlorine and bromine. Okay. So are you okay with that one? Like, I don't think it is difficult. That was very easy. People who got polymer and organic questions, correct? You can check here how many answers are correct. I'll put the marks give also here right after this. Yeah, so we'll stop at that. My battery's also right. So we'll be stopping after that, dear. I'm going to leave from here. Any other issues? Like we discuss the other one later. So we're going to stop. You have the time, right? Okay. It took some time. So we're going to finish starting. Have a good night. Bye. Good night.
Bye, teacher.
Thank you,
Okay.
teacher.
Yeah, okay.
Bye.